Hello students, this is Dilip Udhani, Assistant Professor at LJIET. Today I will teach you case number 3 of Frobenius method. What is that? Roots differing by an integer, that is r1 minus r2, that is not an integer value, right? This is case number 3 where r1 is less than r2. So in this case, we have two possibilities. So in this lecture, we will discuss possibility number 1 only. So what is that? We will see. One of the coefficient becomes infinite for the small initial root r equals to r1. We have two initial roots, one is r1 and other is r2. For the smaller initial root r equals to r1, we will be having one of the coefficient infinite. So the procedure is modified by putting a0 equals to c0 into bracket r minus r1, where c0 is not equals to 0. And the solution will be given by y1 equals to y at r equals to r1 and y2 equals to del y by del r at r equals to r1. And the solution corresponding to the second initial root r2, that is usually a multiple of y1 or a part of del y by del r at r equals to r1. Hence, it produces a linear dependent solution. But we require linearly independent solution to find out the general solution. So the general solution is given by y equals to c1y1 plus c2y2, and this is equals to c1, y1 is y at r equals to r1 plus c2, and y2 is del y by del r at r equals to r1. Okay. Now we will see one example related to case 3, that is example number 1. We have to find out the series solution of the given differential equation about x0 equals to 0. So first of all, we will see this equation is number 1, and we will compare this equation with the standard form p0xy double dash plus p1xy dash plus p2xy equals to 0. So by comparison, we have p0x equals to x square minus x. Now for x0 equals to 0, we have p0x equals to 0 because 0 square minus 0, the result is 0. So if p0x equals to 0 for x equals to 0, then x0 equals to 0 is a singular point. Now we have to check whether x0 equals to 0 is an RSP or an ISP. So for that purpose, what we will do, we will divide the equation 1 by the coefficient of y double dash, that is x square minus x. So we have y double dash minus x over x square minus x y dash plus 1 over x square minus x y equals to 0. Now we will compare this equation with the standard form y double dash plus p of x y dash plus q of x y equals to 0. So by comparison, we have p of x equals to minus x over x square minus x, and q of x is 1 over x square minus x. Okay, right? Now taking x common from the denominator, so into the bracket we will be having x minus 1 and x will cancel out. So p of x is minus 1 over x minus 1 and q of x is 1 over x square minus x. Now we will find out two functions. One is x minus x0 p of x and other is x minus x0 whole square q of x. So in this function we will replace x0 by 0 and p of x by minus 1 over x minus 1. So the result is minus x over x minus 1. So in this function of x we will replace x by 0. So the result will become 0 because in the numerator we have x and we will replace x by 0. So the result will become 0. So x minus x0 p of x is 0 at x equals to 0. Now similarly we will find out x minus x0 the whole square q of x, replacing x0 by 0. So it is x minus 0 the whole square and q of x is 1 over x square minus x. So it will become x square over x square minus x. So taking x common from the denominator, so it will become x square over x into bracket x minus 1. So one time x will cancel out and the result is x over x minus 1. Now again this is a function of x, and in this function replace x by 0 and x is in the numerator, so the result will become 0. So both these functions are defined at x0 equals to 0. So x0 equals to 0 is a regular singular point. Okay. Now let the series solution of equation 1 about x0 equals to 0 is y equals to sigma n equals to 0 to infinite a n x minus x0 the whole raised to n plus r, where a0 is not equals to 0. Now replacing x0 by 0, it will become sigma n equals to 0 to infinite a n x raised to n plus r. Now writing x raised to n plus r as x raised to r into x raised to n. Now expanding this term, we have x raised to r into bracket. For n equals to 0, it is a0 into x raised to 0, so that is a0, plus for n equals to 1, it is a1 x raised to 1, plus for n equals to 2, it is a2 x square plus dash dash dash. Now say this is equation number 2. Now we will find out derivative of this equation. So derivative of y is y dash, and that is equals to sigma n equals to 0 to infinite a n, and derivative of x raised to n plus r, result is n plus r x raised to n plus r minus 1. Now again differentiating this equation, we have y double dash equals to sigma n equals to 0 to infinite a n n plus r, and derivative of x raised to n plus r minus 1, that is n plus r minus 1 x raised to n plus r minus 2. Now substituting the value of y, y dash and y double dash in equation number 1. Equation number 1 is x square minus x, this is y double dash, then after minus x, this is y dash, then after plus y, and this is y. Okay, and this is equals to 0, right? Now multiplying this term by x square and x. If you will multiply this term by x square, so it will become x raised to n plus r, and these terms will be as it is. So it will become sigma n equals to 0 to infinite n plus r minus 1 a n and x raised to n plus r. Now multiplying this whole term by minus x, so these terms will be as it is, and it will become x raised to n plus r minus 2 plus 1. So the result will be x raised to n plus r minus 1. Then after multiplying x raised to n plus r minus 1 by x raised to 1, so it will become sigma n equals to 0 to infinite n plus r a n into x raised to n plus r, plus this term will be as it is, that is sigma n equals to 0 to infinite a n x raised to n plus r. Okay, now we have three terms of x raised to n plus r, this one, and this one. So taking a n x raised to n plus r common from these three terms, so we have a n x raised to n plus r common. So over here we have n plus r into bracket n plus r minus 1. Then after for this term we have minus n plus r, and then after plus for this term we have 1, and this one term will be as it is. Okay, and this is equals to 0. Now we have to simplify this result. Okay, now this term we have written as it is, then after plus a n x raised to n plus r as it is, and we will simplify this expression taking n plus r common. So into bracket we have n plus r minus 1, then after minus 1. So minus 1 result is minus 2, then after this plus 1. Okay, and that is equals to 0. Now we have to make power of x same. So for that purpose, here we will replace n by n plus 1. So it will become sigma from n equals to minus 1 to infinite n plus r plus 1. If you will replace n by n plus 1, so plus 1 minus 1 will cancel out. So we have n plus r, and it will become a n plus 1. And if you will replace the n by n plus 1, so plus 1 minus 1 will cancel out. So it is x raised to n plus r plus this term will be as it is, and this is equals to 0. Now in this expression, first we will put down the value of n equals to -1, and then after we will write this whole expression as it is, starting n from 0 to infinite. So for n equals to -1, so -1 plus 1 will cancel out. We have r, this one r, and this minus sign, okay? And this one will become -1 plus r, or we can say r minus 1. For an plus 1, it will become a0, and x raised to n plus r will become x raised to r minus 1. Then after minus sign, and this whole expression will be as it is, but it will start from n equals to 0 to infinite, and this one term will be as it is, okay? And this is equals to 0. Now equating the coefficient of the lowest degree term to 0, the initial equation is lowest degree term is this one, x raised to r minus 1, and its coefficient is minus r minus 1 a0, equating this to 0, but we know that a0 is not equals to 0, so we have r equals to 0 and r minus 1 equals to 0. So we have two values of r equals to 0 and r equals to 1, and the difference of these two values is an integer value. It means we are in case number 3. Now equating the coefficient of x raised to n plus r to 0, right? So we have to take this term and this term. So writing minus into bracket n plus r plus 1, n plus r, an plus 1, then after plus into bracket n plus r into bracket n plus r minus 2 plus 1 into an, that is equals to 0. And this is true for n greater than or equals to 0. From here make the subject of an plus 1. So we have in the numerator n plus r into bracket n plus r minus 2 plus 1 into an, and in the denominator n plus r into bracket n plus r plus 1. Okay. Now simplify numerator. Multiply n plus r by n plus r, so it will become n plus r the whole square. Then after minus 2, n plus r, then after plus 1, an, and the denominator will be as it is, and this is true for n greater than or equals to 0. Okay. Now applying the formula of a square minus 2ab plus b square. A is n plus r and b is 1. So it will become a minus b the whole square. So it is n plus r minus 1 the whole square into an, and denominator will be as it is. Okay. Now put the value of n equals to 0 and 1. So for n equals to 0, we have a1 equals to r minus 1 whole square upon r into bracket r plus 1 into a0. For n equals to 1, we have a2. So 1 minus 1 is 0. In the numerator, we have r square, and it will become r plus 1, and it will become r plus 2, a1, and so on. Now we have to check for r equals to 0, the value of a1, a2, and so on. So for r equals to 0, if we'll put down r equals to 0 over here, so it will become infinite. So value of a1 is infinite, and a2 is function of a1, so definitely a2, a3, and so on all will become infinite. Okay. Now to obtain the solution of equation 1, that is equation number 1 is, you can see, right, that is the given equation, right? So what we have to do, the procedure is modified, right, by assuming a0 equals to c0 into bracket r minus r1. c0 as it is, r as it is, and the value of r1 is 0. Okay. So c0 into r, the result is c0 r, but c0 is not equals to 0. So substituting the value of a0 equals to c0 r in a1 and a2. So a1 is r minus 1 the whole square, then after divided by r into bracket r plus 1, and a0 is c0r. So r one time will cancel out. We have r minus 1 the whole square upon r plus 1 into c0. So this is the value of a1. Now for a2, r square over r plus 1 into r plus 2, that will be as it is, and multiplied by a1. So the value of a1 is r minus 1 whole square over r plus 1 into c0. So numerator is r square into bracket r minus 1 the whole square into c0, and in the denominator we have r plus 1 the whole square into r plus 2, and so on. Now substituting these value in equation 2, and equation 2 is x raised to r into bracket a0 plus a1x plus a2x square, and so on. You may see equation number 2, right? X raised to r into bracket a0 plus a1x plus a2x square, and so on. So in this expression we have to replace a0 by c0r, and a1 and a2 we have gone through the values of a1 and a2, okay, right? So y equals to, and taking c0 common, so we have y equals to c0 x raised to r into bracket r plus r minus 1 whole square over r plus 1 into x. This is the value of a1, okay. Then after plus this is the value of a2, and we have taken c0 common into x square plus dash dash, and so on. So this is equation number 3. Now for first solution we will put the value of r equals to 0 in this expression. So for r equals to 0 we have y1 equals to y at r equals to 0. So this term will become 0, this term will become 0, okay, and c0 will be as it is, x raised to 0 is 1, so this one will become x, okay. So y1 is c0 x. Now for second solution, putting r equals to 1 in equation 3. So if we'll put down the value of r equals to 1 in this expression, right? So after simplification, you will get y2 equals to again c0 x. That is nothing but y1. Okay. Now differentiating equation 3 with respect to r to obtain the second solution. So del y by del r. So we have to apply the product rule. So this term will be as it is. You can see over here. Then after c0 as it is, and a partial derivative of x raised to r with respect to r, that will be x raised to r into log x, applying the formula of derivative of a raised to x, that is a raised to x into log a. Then after c0 x raised to r, c0 x raised to r will be as it is. Now we have to differentiate this equation. So derivative of r is 1, okay. Now applying the product rule on this term, so definitely x will be constant. First differentiating r minus 1 the whole square, so it will become 2 times r minus 1, and r plus 1 will be as it is. Then after minus x and r minus 1 the whole square will be as it is. Here we will consider plus sign, and derivative of 1 over r plus 1, it will become minus 1 over r plus 1 the whole square. So plus minus minus, it will become minus sign, okay. Plus we will be having terms containing higher powers of r in the numerator. Now we will put down the value of r equals to 0 in this expression, and after simplification we will get y2 equals to del y by del r at r equals to 0. So that is c0 x raised to 0 is 1 log x, this is 0, this will become x, and then after it will become 0, then after plus c0 x raised to 0, that is 1, and this one, then after for r equals to 0 it will become minus 2x, and for r equals to 0 it will become minus x, and these terms will become 0. So finally we have c0 common into bracket x log x plus 1 minus 3x. So this is y2. Okay. Now the general solution is given by y equals to c1 y1 plus c2 y2. So y1 is c0x and y2 is c0 into bracket x log x plus 1 minus 3x. This c1 and c2 will be as it is. Now replacing c1 c0 by a, so it will become ax. Then after c2 c0 by b, so it will become b into bracket x log x plus 1 minus 3x. Now simplifying this result, okay, taking x common from these two terms, so into bracket we have a plus b log x plus b into bracket 1 minus 3x. So this is the required solution of given differential equation. Okay, thank you for watching this video.